Okay, so here we are in Go Math Unit 11.2, and we're talking about surface area. So in the last lesson yesterday in Unit 1, Lesson 1, excuse me, not Unit 1, Lesson 1, we talked about how to find all the different faces of a particular object. If you had a three-dimensional object and you started opening it up, what would it look like? So let's start with a basic box, right? If I look at that box, I ask myself, how many sides do I have? Well, I know I have 6 sides. I have a front, I have a back, I have a left, I have a right, and I have a top, and I have a bottom. And I want to know what it takes to cover that. What is the total surface area? Maybe it's a box that I'm painting. Maybe it's a present that I'm wrapping. I don't know. I need to know the surface area of this particular shape. Well, the first thing that I'm going to do is start with the front and then draw the left, then the back, then the right, and the top, and the bottom. Now I have a net, and this is very important because I have all of my shapes. If a net is beneficial to you, if it really helps, then by all means use it. Draw it out. You're going to be required to do that and recognize that on your test. But if I'm looking at this particular shape and I know that this is 4 inches by 3 inches, and it is 4 inches deep, well, now I can make sense of the rest of this. That means this is 4 inches, this is 4 inches. My back here is 4 inches. The top, if this is 3 inches, because this is 3 inches, then this particular square is 4 inches by 4 inches by 4 inches. If the front is 3 inches by 4 inches, the back is 3 inches by 4 inches. And the left side, if it is 4 inches, the right side's 4 inches by 4 inches, the left side's 4 inches by 4 inches. So now I have them all together. I could go ahead and put this over here. I know that my one is 3 inches by 4 inches, and that means that all of these are 4. So I know that this one is 4 inches, because on the right it's 4 inches by 4 inches. So now this is 3 inches, and this is 4 inches. That means that all of these are 3 inches. So now I could solve every single one of those rectangles. One of the shortcuts that I like to take, and remember, if there's a shorter, easier, faster way to do it, I will show it to you. This is perfectly acceptable. This is also perfectly acceptable, but I know some of you are getting overwhelmed with so many numbers and so many things and going, uh-oh, well, which numbers do I put in for which thing? Take them one at a time. So ask yourself, what is the front? There's a front, there's a side, and there's a top. I'm going to move side over here. 3 main parts. Now I know if there's a front, there's also a back. If there's a top, there's a bottom. And if there's a side, there's another side. But I start with those 3. And I go, okay, the front is 3 inches by 4 inches. 3 inches by 4 inches. Okay? The right side is 4 inches by 4 inches. Nope, I wrote that under top. 4 inches by 4 inches. And the top is 3 inches by 4 inches. In this case, it matters less that I have all of my numbers in here, that I'm making sense of everything. I just need to know what each of those 3 specific ones are. And then I can figure out, if I know what the top is, I also know what the bottom is, okay? So stick with me. My formula is area equals length times width. Again, I've taken this whole shape and I've laid it out. I know all the different pieces that I need to solve. Area equals length times width. So 3 times 4 for my front, that's 12 inches squared. My top is also 3 times 4, which is 12 inches squared. And my side is 4 times 4, which is 16 inches squared. And so then you ask yourself, okay, so if I know all of this information, I'm going to go ahead and erase this net over here, right? I know all of this information. Then what do I really know? Well, I know that the front is 12 inches. Therefore, the back is 12 inches. I know that the top is 12 inches. So then the bottom is 12 inches. I know that the left side is 16 inches, so I know the right side is 16 inches. Now I'm solving this 3 different ways. I've drawn out a 3-dimensional shape, I've drawn out a net, I've worked out each of the individual problems. So this is a lot of work in here to get to a very simple problem. When I add all those together and I ask myself as a double check, how many sides or faces do I have on my 3-dimensional object? Well, I have a front, I have a back, I have a left, I have a right, I have a top, I have a bottom, I have 6. So I need 6 measurements here. Front, back, left, right, top, bottom. I can double check them right there. This is the same thing as our composite shape at the end of Unit 10. All I'm doing now is just making it 3-dimensional, but it's still a composite shape, right? It's still a series of different polygons and things put together that I can solve. Add them all together. So this 12, 14, 16, 18, 20. And I'm going to put my 2 up here. 2, 4, 3, 4, 5, 6, 7, 8. So total, this is 80 inches squared because it's area, surface area. So if I know the front's 20 inches, I know the top's front's 12 inches, the back's 12 inches, the top's 12 inches, the bottom's 12 inches, the left's 16 inches, and the right's 16 inches. They all add up to be 80 inches squared. So let's see what it looks like in your book here really quickly. Now, box is shaped like a rectangular prism. The box is 8 centimeters long. I'm going to take everything that I just did in that first one, and I'm going to simplify it a little bit to try and show you a cleaner way to solve this, so hopefully it makes sense. But you can watch this video again and again and again to have it make sense to you. So I'm going to hide that. I have 3 basic shapes, right? I know that if the bottom of this is 6, this is also 6 centimeters. If the bottom of this is 8 centimeters, this is also 8 centimeters. And if the side of this is 4 centimeters, this side is also 4 centimeters. So now what I have are three quadrilaterals with the dimensions. So I start and I go area equals length times width. There's my formula. Start with the formula. Start with the formula. Let's do the left first. 4 times 6. Well, this side is 24 centimeters squared. I take length times width and I say 4 times 8. This is, front is 32 centimeters squared. Okay? And then I need the top. 6 times 8. This is 48 centimeters squared. Now, I have all 3 of these. 1, 2, 3. I know what each of those 3 sides means. This is where most people make a mistake. They can get that far and then they go, I forgot the last step. Because hidden back here are the other 3 sides. And they're identical to the first 3. So if I know that my front is 32, my back is 32. If I know my top is 48, my back is my bottom is 48. If I know my left is 24, my right is 24. Now let's ask ourselves, ladies and gentlemen, how many sides or lateral faces do you have to this particular shape? Top, bottom, front, back, left, right. 6. So how many measurements will you have here? 6. 2 of each. Somebody might say, well, Mr. W, can't I just add those 3 and multiply by 2? Yes, you can. And if that works for you, please do it. Starting off here, I know that that is 2 plus 2 plus 8 plus 8 plus 4 plus 4 is 28. Carry the 2. And I end up with 2, 5, 8, 12, 16, 20. 208. So total I have 208 centimeters squared. All right? So that was a little faster, it was a little cleaner. There is no substitute, guys. There is no substitute for taking your time and writing out the information. Now, if you're somebody who wants to write out every piece of it, this is a good way to make sense of that. Take your 3-dimensional shape and make it into a net. Label the net A, B, C, D, E, F, whatever it would be, right? Now you have all your shapes. You know exactly what you're solving for. Put all of the dimensions down. And if I were looking at this, the surface area of the box, which measures 8 by 6 by 4. I make a box that goes 8 by 6 by 4. Okay? From there, I can take it apart, and I can make my net, And if you would, it would look something like this. We'll label all of our different sides. And I take it one section of a time. The formula is going to be area equals length times width because I'm dealing in parallelograms. If I figure in triangles into here, I need to change my formula for those particular sides, right? So face A is 4 times 8. So if face A is 4 times 8, that also means that face E is 4 times 8, which equals 32. Because A and E are opposites. C, right in here. C is 6 by 8. Because everything across here is 6. Everything up and down here is 8. So face C is 6 times 8, or 48. Area equals length times width. If C is 48, F is its opposite. 6 times 8 equals 48 centimeters squared. And now I'm left with B and D. Well, I see that it is 6 times 4, which is 24 centimeters squared. And if B is 24 centimeters squared, D is 6 times 4, which is 24 centimeters squared, because they're opposites right here. So if you're somebody who likes to draw your net, draw it. If you're somebody who likes to look at the three-dimensional shape and then just figure out 3 of them and then double that, then do that as well. But when I add all these together, I still end up with 32 plus 32 plus 48 plus 48 plus 24 plus 24. Let me clean that up a little bit. And when I add them all together, I get 8, 2, just like we did previously, 6, 10, 20, 228. 2, 5, 8, 12, 16, 18, 20. I stand corrected. Double check my work. 208. Okay? So, again, looking at my surface area, I need to account for every single surface, not just the 3 that I see. But I can solve for those 3 and realize that every one of those 3's has a partner. And maybe you're somebody who likes a little bit more of a concrete example, so you take your 3-dimensional shape and you organize it out in your net like we did in the last lesson and fill in all of your variables and then solve for every single surface area. When you're done, add them together, take your time, and check your work.